This is SpaceTime, Series 26, Episode 76. Coming up on SpaceTime, discovery of a brown dwarf hotter than the surface of the Sun. Detection of a feeding frenzy echo emitted by our galaxy's supermassive black hole 200 years ago. And it seems the Earth's day was 19 hours long for more than 1 billion years. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered what appears to be a brown dwarf that is hotter than the surface of the Sun. The amazing discovery, reported in the journal Nature Astronomy and on the pre-press physics website archive.org, was detected orbiting a low-mass white dwarf star catalogued as WD0032-317. The white dwarf is located some 1,400 light-years away and has about 40% the mass of the Sun. Its orbiting brown dwarf, subsequently named WD0032-317b, has between 75 and 88 times the mass of Jupiter and a surface temperature of some 8,000 Kelvin. By comparison, the surface temperature of the Sun is 5,778 Kelvin. The extreme surface temperature of the brown dwarf is due to its orbital proximity to the white dwarf, taking just 2.3 hours to complete each orbit. White dwarfs are the exposed cores of stars like our Sun, which have ceased nuclear fusion and lost their outer layers. Once these gaseous outer envelopes are puffed off, all that's left is the white-hot core at the centre of the star. In the case of the Sun, it has a temperature of around 15 million degrees, and that's left to slowly cool over time. Now, white dwarf WD0032-317 is a lot cooler than that, with a temperature of around 37,000 Kelvin. However, the immense radiative heat coming off this core is baking the nearby brown dwarf due to its proximity. Scientists first detected WD0032-317 early in the year 2000 using the European Southern Observatory's Very Large Telescope, the VLT, in Chile. The authors noticed that something was tugging at the star, suggesting that it had a companion. But the wobble was too big to be a planet and too small to be another star, and that suggests that it was a brown dwarf. Orbiting so close means the brown dwarf would be gravitationally tightly locked to the star with the same side always facing it. Scientists estimate surface temperatures on the day side of the brown dwarf would be somewhere between 7,250 and 9,800 Kelvin, while over on the night side of the brown dwarf, temperatures would range from 1,300 to 3,000 Kelvin. Brown dwarfs are failed stars, objects which don't have enough mass to sustain the core hydrogen fusion process needed to make stars shine. However, brown dwarfs do fuse deuterium, a heavier form of hydrogen which includes a neutron as well as the core proton in their nucleus. And those above 65 Jovian masses can also burn lithium. While most brown dwarfs are born as such, others start their lives as spectral type M red dwarf stars. But over time they lose enough mass during their evolution to cease core hydrogen fusion, turning them from red dwarfs into brown dwarfs. Brown dwarfs fit into a category between the largest planets, which have about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which have 75 to 80 times the mass of Jupiter, or 0.08 solar masses. And based on that, what this means is that this particular brown dwarf is very close to being a red dwarf. This is SpaceTime. Still to come, detection of a feeding frenzy echo emitted by our galaxy's supermassive black hole 200 years ago, and it seems that Earth's day was 19 hours long for literally billions of years. All that and more still to come on SpaceTime. Astronomers have discovered that Sagittarius A star, supermassive black hole at the centre of our Milky Way galaxy, emerged from a long period of dormancy some 200 years ago to undertake a feeding frenzy. A report in the journal Nature claims the monster, which is some 4.3 million times the mass of our Sun, awakened as the material came too close and was then torn apart by the black hole's immense gravitational tidal forces. The feeding frenzy lasted for about a year at the beginning of the 19th century before the gravity well once again entered a state of quiescence. The study's lead author, Frederick Marin from the Strasbourg Astronomical Observatory, says no effect was felt on Earth from this event, as Sagittarius A star is some 27,000 light-years away from our solar system. However, the X-ray echo detected by Marin and colleagues, which was emitted around 200 years ago, reveals that the original intensity was at least 1 million times greater than that currently emitted by Sagittarius A star. To get an idea of the increase in intensity of X-ray emissions when the black hole emerged from its quiescent state, it's as if a single glowworm hidden deep in a forest suddenly became as bright as the sun. The findings explain why galactic molecular clouds near Sagittarius A star are shining more brightly than usual. It's because they're reflecting the X-rays emitted by Sagittarius A star 200 years ago. To carry out their research, the authors used NASA's XP Imaging X-ray Telemetry Explorer satellite, which was for the very first time able to detect the polarization of this X-ray light with great precision, and also determine its source, something which had previously been impossible. Rather like a compass, the polarized X-ray light points directly to its source, Sagittarius A star, even though the latter is now virtually extinct. Scientists are continuing to study Sagittarius A star in order to try and determine just how much physical mechanisms are required for a black hole of this size to switch from a quiescent state to an active one. We'll keep you informed. This is SpaceTime. Still to come. Well, a day may last 24 hours on Earth now, but for 1 billion years, it seems an Earth day was just 19 hours long. And later in the science report, Facebook owner Mark Zuckerberg says it was the scientific establishment that called on Facebook to censor posts that turned out to be true. All that and more still to come on SpaceTime. A new study suggests that Earth's current 24-hour-long day didn't gradually happen as the planet's rotation slowed down, but instead changed in spurts. Earth's rate of rotation is governed by various factors, including the gravitational pull of the Moon. Scientists know that the length of an Earth day was a lot shorter in the past because the Moon was closer. Over time, the Moon has stolen some of Earth's rotational energy in order to boost itself into a higher and more distant orbit. It's a process which is continuing today, with the Moon's rate of escape being around 3 centimetres per Earth year. One of the study's authors, Uwe Kirschner from Curtin University, says most models of Earth's rotation predict that the day length was consistently shorter and shorter going back in time. But his report in the journal Nature shows the hypothesis of a slow and steady change in the length of a day over time isn't matching the evidence. And I guess the first question that raises is, how do researchers measure ancient day length? In past decades, geologists used records from special sedimentary rocks preserving very fine-scale layering in tidal mudflats. Count the number of sedimentary layers per month caused by tidal fluctuations, and you know the number of hours in an ancient day. But such tidal records are rare, and those that are preserved are often disputed. Luckily, there's another means of estimating the length of a day. Crystal stratigraphy is a geological method that uses rhythmic sedimentary layering to detect astronomical Milankovitch cycles that reflect how changes in Earth's orbit and rotation affect climate. 2 Milankovitch cycles, precession and obliquity, are related to wobbles and tilt in the Earth's rotation axis in space. The faster rotation of early Earth can therefore be detected in shorter precession and obliquity cycles in the past. The authors took advantage of a recent proliferation of Milankovitch records, with over half the data for ancient times generated in the past 7 years. And this gave them the chance to test an alternative hypothesis about planet Earth's paleorotation. One unproven idea is that the Earth's length of day may have stalled at a constant value in the distant past. You see, in addition to tides in the ocean related to the pull of the moon, Earth also has solar tides related to the atmosphere heating up during daytime. Solar atmospheric tides are not as strong as lunar oceanic tides, but this would not always have been the case. When Earth was rotating faster in the past, the tug of the moon would have been much weaker. And unlike the pull of the moon, the sun's tide instead pushes the Earth. So, while the moon slows Earth's rotation down, the sun speeds it up. Kershaw says this means that when the two opposite forces equal each other, it created a tidal resonance, which would have caused Earth's day length to stop changing and remain constant for some time. And that's exactly what the new data compilation appears to show. Earth's day length appears to have stopped its long-term increase and then flatlined at around 19 hours, roughly between 2 and 1 billion years ago. Now, interestingly, the timing of this temporal stalling intriguingly lies between two of the largest rises in the planet's oxygen levels. The new study thus supports the idea that Earth's rise to modern oxygen levels had to wait for longer days for photosynthetic bacteria to generate more oxygen each day. Kershaw says it's fascinating to think that the evolution of Earth's rotation could have affected the evolving composition of the planet's atmosphere.
There's several factors, I guess. I mean, the Earth is spinning all the time. The moon plays a very important role in slowing down the rotation of the Earth because they are attracting each other and the Earth is rotating around the sun and all this energy is getting conserved in this system. And so if energy is getting transferred from the Earth to the moon, then the Earth has to slow down.
It's not just the sun and the moon which control the Earth's rate of rotation. There's also something else, the Milankovitch cycles. Tell us about them.
That's a very interesting question, first of all, because, in our paper, we took these certain aspects together to get information on the length of day of the Earth, which is related very much on the rotation. But on the other hand, what you mentioned, the Milankovitch cycle, they play a very important role in Earth's climate, in the insolation, let's say, on several places on the Earth. And the Milankovitch cycles are related to not just one thing, but to several aspects of the way Earth is spinning. Like, it's not spinning in the plane of all the rotations, but it has an angle, so it precesses around this angle. That's the precession. It's also the rotation around the sun. It's not a circle, but an ellipse, and this ellipse is not closed. So this changing is affecting the insolation. And also the obliquity. So this angle also plays a role. So these are the three main things. And all these are heavily related to the insolation and has been shown that you can see this in geologic records. So that you can see climate cycles with this wavelength of the Milankovitch cycle.
And what's your research been involved in?
Yeah, that's a bit of a story because I'm not an astronomist. I'm a paleomagnetist. So what I do most of the time is I'm taking small samples. I measure the magnetization direction in these samples. Then I try to figure out the magnetization direction during the time of formation of this rock. And then I reconstruct the continent where I took this sample. So how Australia moved through Earth history. That's kind of my main thing. On the other hand, I'm using the same technique to do using magnetostratigraphy, measuring polarities throughout a section in an outcrop section.
So what happens is as magma cools and solidifies, it develops a north-south pole, and that'll solidify in a certain direction. That lets you know what direction the magnetic poles of the Earth were at the time that rock solidified. It can use that like a strata to date various rocks.
I mean, two things, because the direction of the magnetic field right now is pointing towards the North Pole, so I can calculate the magnetic North Pole, but I can also use the inclination to tell me where I am. Like when I'm at the equator, the magnetic field lines will be perfectly horizontal, whereas here in Australia, I think they're dipping 40 degrees or so. And this is related, so I can calculate the paleolatitude where this place was. On the other hand, the magnetic field reverses its polarity every now and then, and I can use this pattern to try and get the age. Doing this, having a geologic section where I try to figure out the age, I can also measure magnetic parameters to identify these Milankovitch cycles, which then gives me one of the only controls on the duration of a certain outcrop. So we worked on drill cores from the Valkyrie Formation in northern Australia. This is like 1.5 billion year old sedimentary rocks. And there is no chance in deciding very precisely how much time is conserved within a certain interval. The absolute dating is not precise enough, but the Milankovitch cycles can be used to do this kind of things. And that's what, using magnetic parameters, that's more what I'm doing. And the study we did now is like using more of this study, which gives us Milankovitch cycles, which can be used to calculate the length of day and then the Earth-Moon distance and these kind of things, because the precession is related to the length of day.
And by using that, you were able to find out that it wasn't a gradual progression from a shorter day to the 24-hour days we have now. You found that it got stuck on a 19-hour day for a while there. That lasted about 1 billion years.
The thing is, we are doing these things, and it's interesting, obviously, that this evolution of length of day. But then we looked at this very recent compilation of newer data got available, and ours included. And then we had a look more into this in more theoretical papers about all these rotational theories and the tidal aspect. And then we found suggestions that the moon is one side of the story, which is the most dominant, the tidal force of the moon on the Earth's rotation. On the other hand, the sun is heating up the atmosphere, and this is creating another force in the opposite direction. In resonance mode, this is not our research, this is other people have suggested this, and they said if these two forces are in equilibrium, there might be a resonance state which could be as long as 1 billion years or so. We don't know exactly how long. And we took this up and had a look at this, and we did a very basic statistical step change analysis, and we got this interval of fairly stable length of day evolution of about 19 hours a day. And I mean, there's a lot of the uncertainty is still big there, but the fact that we found this with actual data, actual real constraints, which is similar to what other people have suggested, I think that's the most interesting part of this study, actually.
What do you think caused the stall? That's a long stretch of time for the natural slowdown of Earth's rotation to halt.
Yeah, definitely. I mean, these people suggested already that if you're in resonance state, you will stay there and the length of day won't change anymore. What they say, the more interesting thing is how you get out of this mode.
That was my next question. How do you get out of resonance?
If you are in this mode where the atmospheric tide and the lunar tide are cancelling out each other, you will stay there. But what they were saying, you might need sudden increase of atmospheric temperature, which could get you out of this. And there was a two phases of maybe not complete snowball Earth, but a lot of parts of the Earth were covered in ice. And once this ended, because of some reason, there's also debates, a lot of research going on there. But once you get out of this, you might have these couple degrees of sudden temperature rise, and this might have caused the exiting of this resonance state. On the other hand, our data now might indicate this was a bit earlier than these snowball events, so we might reconsider and find other mechanisms to break this resonance state. With more data coming available, our analysis might change slightly, and we might get more closer to this change point, getting out of this resonance state, more in the range where the other people have suggested this, so closer to the snowball Earth event. But it might also be that we have to look for another feature, which is also interesting, because 1.3 up to 1 billion years ago up to this snowball Earth event, that's a very interesting period of time where we were working more from the paleogeographic side of things, where a lot of things happening there, and a lot of also with the magnetic field. This will be interesting how this field evolves in the coming time, and if there's no new aspects evolving there.
That's Uwe Kirscher from Curtin University. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Meta and Facebook CEO Mark Zuckerberg says scientific establishment asked his platform to censor posts about COVID-19, claiming they were misinformation, but which ended up being either true or at least open to debate. The admissions were made on the Lex Fridman podcast while Zuckerberg was discussing the problems Facebook faced on removing misinformation. Zuckerberg says there simply hadn't been time to fully vet a bunch of the scientific assumptions. He said the establishment encouraged him to enforce what he called shaky facts, asking for a bunch of things to be censored that in retrospect ended up being true or at least open to more debate. At the height of the COVID-19 pandemic in 2021, Zuckerberg admitted that Facebook had removed some 18 million posts, claiming that what was being claimed at the time was misinformation about the virus. Last year, several US state attorney generals compiled evidence alleging that Zuckerberg coordinated with White House health spokesman Anthony Fauci to discredit and suppress the hypothesis that the COVID-19 virus may have originated in the Wuhan Institute of Virology. It has since been established that Fauci's National Institutes of Health was funding gain-of-function research on bat viruses at the Wuhan lab. Earlier this year, the US Department of Energy concluded that the pandemic was most likely leaked from the Wuhan Institute of Virology, thereby supporting the earlier conclusions of a separate investigation by the FBI. A new study has found there really is a difference in your heart health depending on whether you're gay, straight or bi. A report in the Journal of the American Medical Association Cardiology claims bisexual biological females may have worse cardiovascular health than their heterosexual peers, while gay men have better cardiovascular health than straight men. The study assessed the cardiovascular health of over 12,000 people and then looked at how their scores varied with sexual identity. The authors say the data suggests that there's a need for tailored interventions to help improve the cardiovascular health of sexual minority adults, especially bisexual biological females. Japan has begun testing new facilities designed to discharge treated nuclear wastewater into the North Pacific Ocean. The contaminated water had been used to cool the melted reactors at the Fukushima Daiichi nuclear power plant, but after filling more than 1,000 tanks, storage is expected to reach capacity early next year. Japan says it's now treated water to the point where officials say it's no longer harmful, and so it now intends to dilute and release that water into the Pacific. Back in March 2011, 3 of the 6 nuclear reactors at the Fukushima Daiichi nuclear power station were destroyed after 14-metre-high tsunami waves from Tohoku undersea earthquake inundated the facility. The earthquake had already triggered an automatic shutdown of the power plant's 3 operational nuclear reactors, the other 3 having already been shut down for maintenance. However, the tsunami flooded and damaged the power station's emergency diesel generators. Those generators were needed to pump water to keep the reactor cores cool during the shutdown. This allowed heat to build up inside the 3 reactor cores. That eventually triggered a meltdown of the nuclear fuel rods inside the reactor, the exact scenario which Hollywood portrayed in the movie China Syndrome. In the case of Fukushima, the molten nuclear fuel rods melted through the base of the reactor pressure vessels and then flowed onto the bottom of the primary containment vessels, forming Medusa. The melting fuel rods also produced vast amounts of pressurized hydrogen gas as a byproduct. This eventually reached a critical stage, venting out of the reactor pressure vessel where it mixed with ambient air. And this eventually reached concentration limits in 2 of the 3 reactor buildings and consequently exploded, spreading vast amounts of contaminated material over the surrounding countryside. A new study has found that babies born to women who use traditional Chinese medicine were twice as likely to have birth defects compared to mothers using no medicine or those using conventional Western medical treatments. The findings, reported in the journal Acta Obstetrica et Gynecologia Scandinavia, compared 16,751 women from 12 different provinces across China. But as Tim Mendham from Australian Skeptics explains, there were some serious problems in the way the study was carried out.
Fudan University in Shanghai did a test of about 16,700 women from 12 different provinces in China, of people giving no medicine, Western medicine and traditional Chinese medicine for women during their pregnancies. And what they were saying is that babies born to women who underwent traditional Chinese medicine treatment were twice as likely to have birth defects compared to mothers who did not, whether they had Western medicine or no medicine at all. Pretty shocking result. They say that a lot of the traditional Chinese medicines carry, quote, a significant risk of fetal malformations. They urged expectant mothers to use the therapies cautiously. So in other words, this is a Chinese university doing a study of Chinese people across China, different provinces, of how they reacted and what the outcome of their children were. If you get twice as many problems with the traditional Chinese medicine, you say, oh, hang on, there must be something wrong. There is a problem with this study, and as always, skeptics like to point out problems with scientific studies, even as much as they do for non-scientific studies. This was a group of 16,000 odd, 12,300 of whom did not take any medicines, 4,000 were given Western medicines, and 189 used traditional medicine. Now, 189 is not a particularly large sample. The 4,000 who got Western medicine is, that's decent.
So it's not a balanced study.
It doesn't seem to be a balanced study, and that's a shame, because it's a great idea. It's sad for the babies, obviously. It's unfortunate that the sample they chose, maybe that number of people in the sample was chosen by the patient. Maybe most of them wanted to do Western medicine rather than traditional Chinese medicine. Who knows? That's the trouble. There's not enough information from the reports that I've seen to actually show what's happened. The interesting thing is they said that of this 189 women who were given traditional Chinese medicine, they were looking at an average rate of 34.6 fetuses per 1,000 that had congenital malformation. So that's a 3.5%, I think it is, if you work it out, of people, which is not compared to 1.5% of those who were not exposed to medicine. So it's a bit of a difference, whether it's a statistically significant difference, considering the low number of people you're talking about. And when you talk about per 1,000 fetuses, there's not an actual 1,000 fetuses amongst the traditional Chinese medicine users. So it's an extrapolation from a fairly small sample base. So this case, interesting concept. This is one case where it does need more work.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.